This is a schematic representing a transport protein. So although we haven't gotten to these yet, this is a representation of a membrane, a lipid bilayer, very important component of what cells are all about. And membranes need proteins associated with them to carry molecules and ions across, compounds across the membranes that otherwise are unable to pass through these lipid bilayers. So an example of a protein is something called a transport protein, which I'm representing here. It's carrying that star across the membrane. So it's helpful to think about the functioning of proteins and the functioning of enzymes without taking into account the chemistry involved, because in order to fully appreciate the chemistry involved, you have to fully appreciate chemistry. And that is no easy task. So what I'd like to do is to introduce you to the ideas of how proteins function in terms of transport molecules, and that way you can understand a physical process which is easy to appreciate. You take something on one side of a membrane and you pull it over to the other side of the membrane. But in many cases is very much like an enzymatic process. It's just that it doesn't involve actually breaking and forming bonds. So this is how transport proteins, not all of them, but some transport proteins work. You'll have some substance that's freely diffusing about, and that substance will bind at a specific location in the protein. In an enzyme, this would be called an active site. And then once binding has occurred, that stimulates the protein to change its shape. Remember, these are machines. They have a stiffness to them. They have defined structures associated with them. They're also somewhat fluid at the same time. In fact, living things exist in an interface between the solid phase and the liquid phase. The solid phase is the structure, and the liquid phase is the potential to be dynamic. And you see that in these proteins. The binding of something to the protein at the right spot, the right thing at the right spot, causes the protein to change shape. In this case, the change in shape takes that something and grabbing it from on one side of the membrane and pulling it through to the other side of the membrane. Once the protein has changed its shape to where it is going to, it, in this case, releases the substance from the protein, which then diffuses away. And at that point, that signals the protein to fall back into its original state. So it's sitting out there, something diffuses into its equivalent of an active site. It grabs that thing, that stimulates it to move the thing to another location, at which point it's stimulated to release, and the release causes the protein to fall back to where it was initially. So it's relaxation to its original state, and now it's ready to grab another thing, another substance, another of the same type of compound and move it across the membrane. So that's a way of thinking about transport proteins. So this is a way of thinking about engines that goes very much the same way. So the engine in your car, you've got an intake of fuel-air mixture. And then you have combustion of that fuel-air mixture. And you have, this all causes things to change within the engine, the position of the pistons. And as the pistons are changing, you have a release of the combustion products and the exhaust. And then the engine goes back to its original state where it can take up more fuel-air mixture, and so on and so forth. The analogy is not perfect, but basically, this is an explicit description of a machine. And an enzyme, you know, you can describe it very much in machine-like terms. So that's a machine. We showed a transport protein, and now we can show an enzyme. And an enzyme works very similarly as well. So you've got an acquisition of the substrate or substrates, the thing that's being acted upon. And that causes a change in what the enzyme looks like, its shape, resulting in pushing the substrate or substrates to their transition state, which leads to catalysis. Once you've catalyzed the reaction, you now have products. And once the products are there, the protein releases those products. And the release of these products causes the protein to relax back to its original state, where it's now ready to acquire new substrate. And it acquires new substrate, it catalyzes it, makes the proteins diffuse away, it goes back to its original state, and so on and so forth. So there truly are little machines. They're specific little machines. The substance that they can act upon tends to be very well defined and represents a limited number and might only be one type of compound. And the products that are produced tend to be very specific as well, often limited to just a single type of a substance. But basically, they're machines that are specialized in grabbing something, doing something with it, and then releasing it and going on to being able to complete the process all over again.